Hello, welcome to the session onto the data structures. Please subscribe to our channel by clicking subscribe button and press bell icon for your personal notifications. Today in this session we are going to have or we are about to learn a data structure overview. In this first session, so we'll be learning data structure, introduction to data structure, type of data structure, and non-primitive data structure and non-primitive, linear and non-linear data structure operations. So linear arrays and then stacks. Let's quickly move on to introduction to a data structure. Computer is an electronic machine which is used for data processing and manipulation. When programmer collects such type of data for processing, he would require to store all of them in computer's main memory. Same is the case with the controllers or any embedded systems as well. In in order to make how computer work, we need to know representation of a data in computer, accessing of data, how to solve problems step by step. For doing all this task we need data structure. So what is a data structure? A data structure is a specialized format for organizing, processing, retrieving, and storing data. In computer programming, a data structure may be selected or designed to store data for the purpose of working on it with various algorithms. Data structure can be defined as a group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. Examples of data structures are arrays, linked lists, stack, queue, etc. Data structures are widely used in almost every aspect of computer science, that is, operating system, compiler designing, artificial intelligence, graphics, and many more. So, data structures are the main part of many computer science algorithms as they enable the programmers to handle the data in an efficient way. It plays a vital role in enhancing the performance of a software or a program, as the main function of the software is to store and retrieve the user's data as fast as possible. A data structure is a particular way of organizing data in computer so that it can be used effectively. For example, we can store list of items having the same data type using the array data structure, just like this. So array is having indexes 0, 1, 2, 3, 4, 5, 6, and the elements you have is U, B, F, T, and so on, and it will have address on top. The representation of a particular data structure in the main memory of a computer is also called as storage structure. The storage structure representation in auxiliary memory is called a file structure. It is defined as the way of storing and manipulating data in organized form so that it can be used efficiently. A DS mainly specifies the following four things. One is organization of data accessing method, 3 degree of associativity, and 4 processing alternative for information. Algorithm from plus data structure equals to program. Data structure study covers the following points. 1. Amount of memory required to store. 2. Amount of time required to process. 3. Representation of data in memory. And 4. Operations performed on data. We have uh, types of data structures. Data structures are basically divided into or classified into two. One is primitive data structures, and the second one is non-primitive data structure. Non-primitive data structure, once again, is divided into two types. One is linear data structure, another one is non-linear data structure. Here you can see in this figure data structure, built-in data structure, and user-defined data structure. Right, integer, float, character, pointer are built-in data structure. Arrays, lists, files, etc. are all user-defined data structure. In array, you will have one-dimensional array, two-dimensional array, and so on. Whereas in the lists, linear lists, non-linear, the stack and queue belongs to the linear list, and the non-linear list, tree and graph. We'll look into it later in the later part of this session. A particular kind of a data item as defined by the values, it can take the programming language used or the operations that can be performed on it. Those are all data types. Primitive data structure are basic structure and directly operated upon by machine instructions. Primitive data structures have different representations on different computers. It's obvious, right? It is machine instruction operated by machine instruction. So it differs from computer to computer or a system to a system. Integers, floats, characters, and pointers are the examples of primitive data structure, which we saw in that figure earlier. These data types are available in most programming languages as built-in type. We know how to code with C, C++, Java and all. So integer is a data type which allows all values without fraction part. We can use it for whole numbers. Float is a data type which is used for storing fraction numbers. Character is a data type which is used for character values. Pointer, a variable that holds memory address of another variable, are called pointer. These basics we already know, but it's my duty to recall it. So let's move on to the non-primitive data type. These are more sophisticated data structure. So these are derived from primary or primitive data structure. The non-primitive data structure emphasize structuring of a group of homogeneous or heterogeneous data items. The example of a non-primitive data type are array, list, and file, etc. We'll look why it is called non-primitive, because they are built with the same integer, character, float, or pointer, something like that. With primitive data structure itself, it is rebuilt whether as a group of homogeneous or heterogeneous data items. A non-primitive data type is further divided into linear and non-linear data structure: array, list, file. Okay, array is a fixed size sequence collection of elements of the same data type. Suppose I have a character A with a square brackets with a size 10 or a dimensions 10. Dimension size is 10. You remember that, right? List, an order set contains variable number of elements, is called as list. A file is a collection of logically related information. It can be viewed as a large list of records consisting of various fields. Let's dig a little deeper into linear data structure. A linear data structure simply means that it is a storage format of the data in the memory, in which the data are arranged in contiguous blocks of memory. Example is the array of characters. It represented by one character after another. In the linear data structure, member elements form a sequence in the storage. We'll look into a figure, then we'll understand what it is. The linear data structure, member elements form a sequence in the storage. There are two ways to represent a linear data structure in memory. One is static memory allocation and another is dynamic memory allocation, if you remember. So the possible operations on the linear data structures are traversing, insertion, deletion, searching, sorting, and merging, which is common. I repeat, the possible operations on the linear data structures are traversing, 2 insertion, 3 deletion, 4 searching, 5 sorting, and 6 merging. Okay, see the difference between an array and a linked list. So array sequence, linked list will have the address of the next node or something like that. Typical features in arrays: indexing, length or size, copying. Typical features in a linked list is get next element, insert element, remove element. So array is good for storing a fixed number of things and doing something to everyone on those things. Whereas the linked list is good for dealing with a dynamically changing list, that is where you may need to insert or remove elements from anywhere in the list. If you remember the programs, add a node, at the third after the third element of the linked list, remove a node, remove the last node or first node, like that. So example of linear data structures are stack and queue. Stack is a data structure in which insertion and deletion operations are performed at one end only from the top or bottom, not both ways. See here, if you remember push pop, which we discussed in the microcontrollers and all those stuff, right? So the insertion operation is referred to as push and deletion is referred to as pop operation. Stack is also called as last in first out, that is LIFO data structure. Remember, stack is also called as last in first out. Obviously first in last out or last in first out data structure. Next is queue, the data structure which permits the insertion at one end and deletion at another end, known as queue. Queue, it's just, we all know about queue, right? Which permits the insertion at one and deletion at another end, known as queue. End at which deletion occurs is also known as front end, and the other end at which the insertion occurs is known as rear end. Queue is also called as FIFO, that is first in first out. So Remember the difference. Stack is LIFO, lost in first out, and queue is first in first out. Okay, let's move on to non-linear data structures like tree and graph. Non-linear data structures are those structures in which the data items are arranged in sequence. Example, tree and graph. A tree can be defined as a finite data item nodes in which data items are arranged in branches and sub branches. So you can look at the left. Okay, the items are arranged in branches and sub branches. That's what a general tree is looks like. Data structure tree is also like that only. You have a root, level, node, edged or link, subtree, leaf, like that. Tree represents the hierarchical relationship between various elements. Tree consists of nodes connected by edge, the represented by circle, and edge leaves connecting to circle. After this, we'll look at the components of a graph. A graph is collection of nodes, that is information, and connecting edges logical relation between nodes. You can look in this. Graph is collection of nodes, that is information, and connecting edges, that is logical relation between the nodes. A tree can be viewed as a restricted graph. Graph have many types. One is simple graph, mixed graph, multigraph, directed graph, and directed graph. We'll dig deeper later on all these linear data structures and non-linear data structures in the further sessions with example, algorithm, and how to uh, solve the situations, if at all we have situations in the later sessions. So please kindly subscribe by clicking subscribe button. Let's move on to the difference between this linear and non-linear data structure. So every item is related to its previous and next items in linear data structure. Whereas in non-linear, every item is attached with many other items. Alright, that's the basic difference between linear and non-linear. That means every item is related to its previous and next item, but whereas here it is scattered. Every item is attached with many other items. We just saw in the tree and graph, right? Whereas array and a linked list, it's not so. So in linear data structure, data is arranged in a linear sequence, whereas data is not arranged in a sequence. Data items can be traversed in a single run. Data cannot be traversed in a single run here. Example, we know array, stack, linked list, queue, etc. Example here, tree graph. Implementation is easy, whereas in the linear data structure, implementation is a bit difficult, but not impossible. Let's look at some of the operations on data structures. Design of efficient data structure must take operations to be performed on the data structure into the account. DS, the most commonly used operations are: 1. Create. This operation results in reserving memory for memory elements. This can be done by declaration statement. Creation of data structure may take place either during compile time or runtime. When we create, we should have also an operation called a destroy. So this operation destroys memory space allocated for specified data structure. Then selection of a particular data structure. This operation deals with accessing a particular data within a data structure. Next is updation. If updates or modifies in the it updates or modifies in the data structure. Searching, we need to search, right? If it finds the presence of desired data in the list of data items, it may also find location of all elements that satisfy certain conditions. Then when you are good able to search, we should able to also sort it. Sorting is a process of arranging all data items in a data structure in a particular order, for example either ascending order or in descending order. Or splitting is another operation. It is a process of partitioning single list to multiple lists. Okay, if for example I have data of students, so I have to split it into the male students and female students, or differentiate between 30 percentage students, 30 percentage market students in one list, and 30 to 45 in one list, and 45 to 60 is another list, 60 to 90 is another list, or 60 to 100 is another list. We could able this process is very essential in our regular operations, right? We need to partition. Next is merging. It is a process of combining data item of two different sorted list into single sorted list. Next is traversing. The same, take the student class item. So traversing is a process of visiting each and every node of a list in systematic manner. What are arrays? Let's look to array, how it looks like. Array is a container which can hold a fixed number of items, and these items should be of the same type, right? Suppose if I say int a, okay, we will have all integer elements in that. Okay, character a will have all character elements, or float, whatever it is. Okay, so most of the data structure make use of arrays to implement their algorithms. Too important is element index. So detailing these two, look at this concept diagram. You have an array and we have index of the array and elements within the array. Okay, an array is a container of elements, right? We have elements, the two number is representing elements and one is representing array. Elements have a specific value and data type like ABC, true or false, or some other 1 2 3, like that, based upon the data type, right? Each element has its own index which is used to access the element. Suppose I have this array name as a of 0 represents character a, right? A of 2 represents character c, like that. Let's understand the syntax in C or C++ as well as Python. Elements, look at the here, elements are stored at contiguous memory locations. See, balance is equal to array, and the elements are stored at contiguous memory locations, and index is always less than the total number of arrays. See, here we have an array with 3. Okay, array name of 2 represents what here. In terms of syntax, any variable that is declared as an array can store multiple values. Almost all languages have the same comprehension of arrays but have different ways of declaring and initializing them. However, 3 parts will always remain common in all the initializations, that is array name, elements, and data type of elements. Hope you understood the syntax of array. Let's move about accessing array item. How to access a specific array value. You can access any array item by using its index. Array name, index number, as simple as that. Suppose I want to access second element, that is 0, 1, 2 represents the 3 this thing. I have to write the array name of 1. Let's assume in the previous example itself we have a balance, an array called balance, right? Example. So let's look at it, how it is. So we have accessed the second value of the array using its index. Index of the second value is 1 because it starts with 0, 1, 2. If the dimensions size is 3, that index will start with 0, 1, 2. Okay. So the output of this value would be 200 when you print it. Let's see how it is represented. For illustration, let's take an declaration. Okay, in the different languages. Integer array of size 10. I should have 10 elements, right? But the index would start as array of 0 is 35, 1 array of 1 is 33, and 2 is 42, and so on to 9, 0 to 9. Thank you for your attention. We'll discuss much further about this in the coming sessions, much deeper and much advanced as well. Thanks for your requests. I hope this would be helpful for people. Please subscribe to our channel by clicking subscribe button and press bell icon for your personal notification. Thank you once again.